Hello everybody, today we're going to talk about molarity. First of all, molarity is another form of concentration that we're learning in this unit. It's one that we're going to use a lot, so it's a good one. Molarity is calculated by taking the moles of solute and dividing it by liters of solution. It's represented by a large M. So just remember that this equal sign means that big M and moles per liter are the same thing. And so that's kind of an important thing for us as we move forward. A molar solution contains 1 mole of solute per liter of solution. So again, that per right here tells us division. So solute divided by volume. All right, so here's our first problem, model problem 12-5. It says calculate the molarity of a solution produced by dissolving 11.5 grams of solid sodium hydroxide in enough water to make 1.50 liters. So our question is molarity. So again, as soon as I see calculate the molarity, I go, okay, molarity equals moles of solute per liter of solution. That's my abbreviation for solution. I hope you're all okay with it. Okay, great. We have been given 11.5 grams of our solute. We have been given 1.50 liters of solution. So I set them up like this. Now, what's the problem? Grams is not moles. So what do I need to do? Can I get from grams of sodium hydroxide to moles of sodium hydroxide? The answer is yes. So I'm going to hit times, and I'm going to use the molar mass. All right, so now my grams of NaOH cancels, and I have moles over liters, which is what I'm looking for. So all I need to do now is do the calculation. And I get 0.192 moles per liter of NaOH. But remember, anything that is moles divided by volume, you can substitute in the big M. So we could also answer 0.192 molar sodium hydroxide. So when we're calculating molarity, we don't necessarily say 0.190 molarity sodium hydroxide. We just use the word molar. So a molar solution is a molarity calculation. Okay, let me erase that. All right, next one. 12.6 or 12-6. Give the concentrations of all of the ions in a 0.50 molar cobalt-2 nitrate. So what are we going to do here? We need the concentrations. We are given the molarity of our substance. So one of the first things we're going to do is write a dissociation equation. So it's important that we know that this means that the compound is going to dissociate. To dissociate is to separate. And it's going to separate into its ions. So from the formula, I can see that there's 1 cobalt, which has a 2+ charge. And that 2 tells me I have 2 nitrates, which has, I'm going to put a 2 in front of it. All right. We have been given a 0.50 molar, right? Or I can change this to moles per liter if needed. And the question is, what is the concentration of this and what is the concentration of this? All right, so those are the 2 things. We're looking for 2 things. All right, this is 2 questions. Let me go ahead and erase this, and we'll let the PowerPoint do its magic. Notice that each formula unit contains 2 nitrate ions and 1 cobalt ion. And again, re-emphasizing that big M means moles per liter. So we're going to start with our cobalt nitrate, cobalt-2 nitrate, and we have 0.50 moles per liter. Guess what we're going to do? What is this? Well, is there a stoichiometric relationship between cobalt-2 nitrate and our nitrate ion? The answer is, if you said yes, you are correct. All right, so for every 1 mole of cobalt-2 nitrate, there are 2 moles of nitrate. So we're gonna then moles of this and moles of this cancels, and look what we've got left is just our moles of nitrate. This is still moles over volume though, so that is important as well. So again, 1.0 moles per liter, which we could, if we wanted to, also trade these units out for a big M, but it's not necessary. Now we're going to do it a second time because again, this problem had 2 questions. It wants to know both ion concentration. This time our stoichiometry is 1-to-1 with the 2 ions. So the molarity is going to be the same. All right, so it's going to be 0.50 moles per liter of the cobalt 2+ ion. We're going to box out both of them because again, this question had 2 questions, or was looking for 2 answers. All right, here we go. 12-7. How many moles of silver plus 1 ions are in 25 mils of a 0.75 molar solution of silver sulfate? Now again, silver sulfate is an ionic compound. All right, and that means it's going to separate into 2 Ag+ ions and 1 sulfate ion. All right, so we have a 2-to-1 relationship. We are we are looking for how many moles of silver ion, and we are given 25 milliliters of a 0.75. Now, it is molar, but I like to change that big M into moles per liter. I'm going to do a substitution so that I remember that this is a relationship that I can use as a conversion factor between moles and volume, liters, or between volume and moles, depending on what the question is asking me. So I have to think about, what am I trying to do? I want to know moles of this. Oh, hey, I can do stoichiometry. If I can get moles of this. So now I'm going to look. Using this volume and this molarity, can I get from volume to moles? Yeah, I can. I got a hurdle though. That's milliliters, that's liters. So before we can use our molarity, we're going to have to convert from milliliters to liters. Then we can use our molarity, go from liters to moles. Then we can do our stoichiometry, 1 mole of this for every 2 moles of that, and boom, we're done. So let's get going. We're going to start back here with 25 milliliters. So in this first step, we're taking 25 milliliters, and we are going to take, for every 1 milliliter, using our metric prefixes, there are 10 to the -3 liters. The only thing we've done here is convert from milliliters to liters. Now that I have, I'm going to erase this, sorry. All right, now that I'm in liters, I can use my molarity. So the next step is, for every 1 liter of silver sulfate, there's 0.75 moles of silver sulfate. That is my molarity right here. Okay, so what's going to happen here is liters of silver sulfate cancels, and we are left with moles of silver sulfate. Eye on the prize, I'm in moles, that's good. But I need moles of silver. I'm not there yet. So now we're going to do that stoichiometry. And that stoichiometry was going to be 1-to-2. And let me write that again just to be clear. Ag2SO4. Okay, so our mole ratio is 1-to-2. So we're going to write that down. So for every 1 mole of silver sulfate, there's 2 moles of silver. Okay, that cancels. Now, the only units I'm left with is moles. The only substance I'm left with is silver. that means it's time to do the calculation. So you're going to grab your calculator, you're going to take 12 or 25 times 10 to the minus 3 times 0.75 times 2 and hit equals, because you're not going to divide it by 1. All right, answer. 3.8 times 10 to the minus 2. Because it is less than 0.1, you have to put it in scientific notation. Okay, here we go. All right, standard solutions. This particular slide talks about how to create a molar solution. And we have what are called volumetric flasks, and they are calibrated for a precise volume. So when you are creating a molar solution, the concentration is accurately known, and it's made by mixing a known amount of solute with a known amount of water in a volumetric flask. Oops, let me come back here. Not hard to do. So again, these are calibrated for a very specific amount. You can measure out your grams of solute, which you know how many moles that would be, and then basically you're going to fill with water to the mark and mix it up. All right, last problem for me, 12-8. How many grams of solid potassium dichromate are needed to make 1.30 liters of a 0.200 molar solution? All right, how many grams of solid potassium dichromate? We have the volume and we have the molarity. So if I have the volume and I can change this to 0.200 moles per liter, again, liters, can I get to moles? Yes. And if I can get to moles, can I get to grams using the molar mass? That is the path. Let's take it. So we're going to start with our volume, 1.30 liters. We are going to use the molarity, and we don't need, it's in liters and this is in liters. So again, our potassium dichromate is going to cancel. We have our moles now. So if we were to stop right now, we're in moles of potassium dichromate. We don't want moles, we want grams. So the next step then is to calculate and use the molar mass. So now my moles of potassium dichromate cancels. I'm now in the unit of grams, and we're gonna do our calculation, and our final answer is 76.5 grams of potassium dichromate are needed. That's it.